Hello good day viewers. In this tutorial we are going to learn how to evaluate one-sided limit, and as you all know we have different type of functions, so we're going to start with rational functions, thereby tagging this lesson as number 1. And in this tutorial we are going to evaluate only these 3 problems. So let's start with the first one. Alright, and here is our first problem. We would like to evaluate the limit of the function 1 divided by x minus 5 as the value of x approaches 5 from the right. This plus sign indicates the direction where we are approaching the 5. Since it is positive, it means we are approaching 5 from the right. For example, if we have a number line like this, we have maybe 0, 1, 2, 3, 4, 5, 6, 7 up to positive infinity. I remember that our point of interest is 5. So we are approaching this 5 from the right, from positive infinity towards 5. So first thing we need to do here is to substitute directly the value of x equal to 5 and see what happens. If we substitute x equal to 5, we have 5 minus 5, which is equal to 0. So this is equal to 1 divided by 0. It does not mean that our denominator is equal to 0, but it is approaching 0. And you should know that the smaller the denominator becomes, the larger the whole fraction tends to be. Therefore, this will approach infinity. But which infinity? Is it a negative infinity or a positive infinity? We can find out by testing these values. If you observe, all values to the right of 5 are greater than 5. And anyone you take, you substitute it here, you're going to get a positive result. You can test 6. 6 minus 5 is 1. You test 7. 7 minus 5 is 2. If you come closer to 5, the values will keep on reducing. We can take 5.1, 5.2, 5.00001. All these numbers are greater than 5, and hence we are going to get a positive number here. So it is approaching 0 from the right, meaning the whole of this is going to approach positive infinity. Therefore, the answer to this problem is positive infinity. And you can also graph it. Let's sketch it and see what the behavior. If we have y and x axis like this, you should know that x can never be equal to 5, right? So we have a vertical asymptote at that point. So suppose we have 5 here. We're going to draw a dotted line like this. So the graph will look somehow like this. Somehow like this. So one thing you should observe, if you're approaching 5 from the right hand side, look at it. From the right hand side, as you approach 5, the curve will tend to deflect towards positive infinity, right? This is why we say the limit of this function as x approaches 5 from the right, it is going to become positive infinity. What if you decide to approach it from the left hand side? Suppose we have 5 to the negative. So if you're approaching from the left hand side, it will deflect once it reaches 5 towards negative infinity. This is why left and the right hand side limits are not always equal, and they have to be equal for the limit to exist, right? So we have proven that the limit of this function as x approaches 5 from the right is equal to positive infinity. Let us take the second one. Alright, here is the second problem. We would like to evaluate the limit of the function x squared minus 1 divided by 2x plus 4 as the value of x approaches negative 2 from the right. Let us draw a number line. Suppose we have a number line here. We have 0 at the center, we have 1, we have 2. To the left, we have negative 1, we have negative 2, in that order. So we are approaching this value right here, which is the number of interest, from the right. You should know that all these values to the right are greater than negative 2. But let us substitute negative 2 directly and see. If you substitute negative 2 here, you have negative 2 squared is 4, and 4 minus 1 is 3. To the top, we have 3. To the bottom, negative 2 times 2 will give us negative 4 plus 4 is 0. it does not mean our denominator is equal to 0, but it is approaching 0. Therefore, since the denominator is becoming smaller and smaller, this will tend to what? Infinity. But is it a negative infinity or a positive infinity? Let us test some values here and see. We can test a value which is very close to -2, for example, -1.999, for example. If you test it here, already -1.999, if squared, it is going to become positive, greater than 1. So this will remain positive. What about the denominator? If you test -1.999 here multiplied by 2 will still be less than 4. And 4 minus that will give us positive number. This implies that our limit is approaching positive infinity as our final answer. So this is equal to positive infinity. And let us graph it and see. Suppose we have y-axis like this, x-axis. You should know that x cannot be -2, right? So at -2, this is -1, this is -2. We have a vertical asymptote here. And the graph will look somehow like this. We have something like this. Something like this. Observe, as you approach -2 from the right, look at it. As you're coming towards the right hand side, it will deflect towards positive infinity. And as you're coming from the left towards -2, it will deflect towards negative infinity. Can you see that? The left hand side limit is not equal to the right hand side limit. So this is all about question number 2. Let us move on to the last one. All right, here is our last problem. We would like to evaluate the limit of the function x squared plus 5x plus 6 divided by x squared plus x minus 2 as the value of x approaches 1 from the left hand side. Let us draw it first. This is our number line. We have 0 here. We have 1. We have 2 to the left. We have -1. We have -2. This is our point of interest. And we are approaching this value from the left hand side. What happened? Let us first of all substitute x equal to 1 and see what happened. 1 squared is 1 plus 5 times 1 is 5. Then plus 6, you can see all this is going to give us a positive number, right? Which is equal to 12. Divide by 1 squared is 1 plus 1 minus 2. This is going to give us 0. And as the denominator approaches 0, the whole fraction will approach infinity. So we have infinity. But is it a negative infinity or a positive infinity? We can test values closer and closer to 1, right? We may have 0.9999, which is very closer to 1, right? This value right here, 0.999. What happened? But do you know that we can factorize this? To the top, we can think of two numbers we can multiply to get 6. And when we add them together, we get 5. And the numbers are 3 and 2. So we have x plus 2 and x plus 3. To the bottom, think of two numbers that you can multiply together to get -2, but when you add them, you get the coefficient of x, which is 1. X plus 2, that is 2, and x minus 1. And from here, you can directly cancel this. So you have only x plus 3 divided by x plus 1. And still, if you apply your limit directly, you have 1 minus 1, which is 0, and 1 plus 3, which is equal to 4. So our numerator is already positive number. So if you take a value which is very closer to 1 from the left hand side, it is going to become less than 1 because 0.999 is less than 1, and 0.999 minus 1 will give us a negative number. This implies that our limit is approaching what? Negative infinity. So therefore, this is equal to negative infinity. Let us graph it and see. Suppose we have our y-axis and our x-axis. You should know that x cannot be equal to 1, right? Because at 1, the whole system is undefined. So we have a vertical asymptote at 1. Something like this. and our graph is going to be something like this and something like this. So as you approach 1 from the left hand side, because this is 1 from the left hand side, the moment you reach closer and closer to 1, the graph will deflect. The values of y will tend to be smaller and smaller, approaching negative infinity. Can you see that? Therefore, the limit as x approaches 1 of this function from the left hand side, it is going to tend to negative infinity. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.